We're going to see how to create a high alarm using timers and thresholds with structured text. First, let's declare our variables at the top. We have function block instances, TempCheck, timer1, and alarm block. Then we have status and sensor variables, unit on, in sensor OK, and out sensor OK. Next, the values and settings current temp, temp limit, and time delay. Finally, the alarm info variables alarm ID, temp alarm, and alarm out. Now that all variables are declared, we can go to the main logic, the main alarm control. First, we check if the unit is on with if unit on then. Inside, we call our function blocks, TempCheck, timer1, and alarm block. Then we check if both sensors are working if in sensor OK equals false and out sensor OK equals false then. If the sensors are OK, we enable the temperature check, tempcheck.zenable equals true. We assign the current temperature to the input, tempcheck.ren equals current temp. The high threshold is set with tempcheck.rcutin equals temp limit, and the low threshold tempcheck.rcutout equals temp limit, 1.0. Next, we configure the on-delay timer. Timer1.in equals tempcheck.xout and timer1.pt equals time delay *1000 to convert seconds to milliseconds. The output of the timer goes to temp alarm equals timer1.q. Now, we configure the alarm block. Alarm block.xAlarm condition equals temp alarm and set the alarm ID. Alarm block.UI alarm ID equals alarm ID. Finally, the main alarm output is alarm out equals temp alarm. If the sensors are not working, we reset everything. Temp alarm equals false, alarm out equals false, tempcheck.zenable equals false. If the unit is off, we also reset everything the same way. All logic is now ready, so we can compile and download the program. Now let's run the simulation in live debug mode to see how it works. We can change current temp to test the alarm. For example, if current temp exceeds temp limit, the timer starts. After time delay seconds, temp alarm becomes true, triggering alarm block and setting alarm out equals true. When the temperature goes below the threshold, the alarm resets automatically. This way, we successfully manage high-temperature alarms using timers and thresholds and structured text with live debug in the end to make sure the program works fine.